What about here? Which is the side facing this angle? That is EF. We say that the side BC corresponds to, this arrow mark should be read as corresponds to EF. So these are called corresponding side. Now we will take up this angle. Angle B is equal to angle E. So let us show it like this in our figure. So this is the AC is the side facing this. Here DF is the side facing this. Therefore we write side AC corresponds to side DF. Finally children, angle C and angle F are equal. So these two angles are equal. And which are the sides facing them? That is AB and D are the corresponding sides. So read this arrow mark as the corresponding sides. It corresponds to. This we call it as corresponding parts. Parts means here a triangle will have sides and angles. That is called as a parts. So corresponding parts of similar triangles, and this we briefly call it as CPST, corresponding parts of similar triangle. Can you recall CPCT children, which you have understood in 9th standard? Corresponding parts of congruent triangles. So CPST and CPCT you must remember, so that while writing the proof we are going to use these terminologies. Okay, now let us now understand the second property of similar triangles. This is with regard to the corresponding sides. Any idea children, how about the corresponding sides? Any idea you have? The property with regard to the corresponding sides. Let us consider the same figure. So this is property number 2. Let us take a scale and try to measure the side AB. Let us suppose that it is 6 centimeter and D happens to be 3 centimeter. Definitely AB is longer than D. I am not happy with that. I wanted to know how many times AB is longer than D. For that, yes, we have to take the ratio. So let us consider the ratio. AB upon DB. AB is how much? In this case, it is 6 centimeter. DE is 3 centimeter, which is equal to 2 in this case. Which means that the length of AB is 2 times the length of DE. You keep this in your mind. Now, let us compare these two corresponding sides. For BC, EF is the corresponding side. Let us say that this length of BC is 8 centimeter and the length of EF is 4. Let us compare by taking the ratio. So, BC upon EF, it is 8 by 4. Oh, we got 2 only. You can see here, this is twice this, and this side which corresponds to this, and this is also twice EF only. What about the third and the last pair of side children? Let us assume that, consider that this has 4 centimeter, this has 2 centimeter. So compare by taking the ratio. So we got 2 only. So if two triangles, if they are similar children, if you take the ratio between the corresponding sides, then if this by this is equal to 2, then this side by this side will also be 2, and finally this by this will also be 2 children. Okay, this is another very, very interesting property. So we say AB by DE, BC by EF, CA by FD, all the 3 ratios, they are equal to one another, and in this case, only in this case it is called 2, which means what this 2 is telling us? It tells us that each side of triangle ABC, each side of this is twice that of the corresponding sides of triangle DF. This is possible only when they are similar, not otherwise. If two triangles are similar, if you take the ratio between the corresponding side, they will be all property, amazing property, and 2 is called as the constant of proportion or proportionality constant. So can we, or what can you infer from this, children? Can you infer anything? What is your conclusion? Okay, we will conclude like this. Okay, so these are the corresponding sides, and we took the ratio, and in the example we got 2, and in general we will write it as K for proportionality constant, and we can write it as, if 2 triangles are similar, you know the first property, but the second property is this, the corresponding sides are in a, what do you want to write there, children? Can I give you some small tips for you? Please observe here. If 2 ratios are equal, here there are 3 ratios are there. So if 2 or more ratios are equal, then we use the word proportion. Proportion means if 2 ratios are equal, then we use the word they are in a proportion. So what can you write there, children? Can we write that they are in a proportion? Do you agree with this? Yes, this is one ratio, another ratio, all of them are equal. Therefore, we say that the sides of triangle ABC are proportion to the sides of triangle DEF. This word proportion is very, very important. So, from here onwards, we will call K as the constant of proportion or proportionality constant. Okay, if 2 triangles are similar, children, then what is that we have realized? That the corresponding sides are in a proportion. Now, what is your next task should be? Don't you think for this statement, you must write the converse? Do you know what is the converse, which I have discussed already? Come on, tell me the converse to this. Yes, you are right. Yes. Okay. Now, conversely, we can put it as, if the corresponding sides of 2 triangles are in a proportion, then definitely the 2 triangles will be similar. This is the converse. If they are similar, corresponding sides are in a proportion. Conversely, if the sides of this are in proportion to that, then definitely they will have the same shape. Once they have the same shape, we call them as similar. So these are the 2 fundamental properties of similar triangles. So let us sum up this, whatever properties we have understood. So we are talking of the triangles having the same shapes only. So if 2 triangles are similar, then we have 2 fundamental properties. The first property says that they will be always equiangular, and the second property is the corresponding sides will be always in a proportion. So these are the 2 fundamental properties which I learned in this session. Okay, children. Now here is a small question for you. We will give you pairs of triangles, 10, 15, 20 pairs of triangles we will be given to you. So, and we will be asked to find whether they are similar or not similar. How to find out or how to demonstrate this practically? Can you think for a while? We will give you some pairs of triangles to you. In KG cardboard or on the board we will draw and give you. And you will be asked to find out which triangle is similar to another triangle. So this is the small task will be given to you. Do you think that is it just fair to decide by just looking through eyes? Let us look the 2 similar triangles like this and say that, oh, they look like having the same shape, or they may not have the same shape. Do you think that this is scientific, or is it possible to decide with the help of the 2 fundamental properties which just now we have discussed? Can you think for a while, children? You have 2 properties with you. Can you use that and find out that the pairs of similar triangles. Okay. According to the first property, if two triangles are similar, then they will be equiangular. This is the first property. If two triangles are given and asked to show that they are similar or not similar, then it is enough that we show that they are equiangular. Take protractor, measure, find out whether they are equiangular or not equiangular. Equiangular means immediately you can conclude that they will have the same shape and hence they are similar. So, this is in fact, we are using not the first property, we are using the converse of the first property and decide. So no need to decide by just looking, apply the converse of the first property and decide. Children, let us remember this as test number 1. According to this test, find out whether they are equiangular or not. If they are equiangular, straight away you can say that they are similar. Or, we have one more property. Come on, think for a while. Okay, yes. Or, according to the second property, if two triangles are similar, then the corresponding sides are in a proportion. So, in order to show that they are similar, it is enough. It is enough if we show that the measurements of the three sides of one triangle are in proportion with the measurements of the corresponding sides of another triangle. Take scale, measure all the three sides, then take the ratio. If the ratio between the corresponding sides in all the three sides are the same, then also you can decide that they will have the same shape, hence they are similar. So, this is in fact the converse of the second property. Let us remember this as test number 2. So, we have two fundamental properties of similar triangles. One is regarding the angles and the other with regarding to the sides. So, we have two methods or two practical tests. We have made use of the converse of the two properties in order to show that the triangles are similar. So, to conclude, children, if two triangles are similar, then the first property is the triangles are equiangular and the corresponding sides are in a proportion. Now, here is a final task for you. Is there any mathematical relation or interdependency between the equiangularity and the proportionality, children? Do you follow this question? I will explain you a little. If two triangles are equiangular, can you say that the corresponding sides are in a proportion? Or if the corresponding sides are in a proportion, then can you come back and say that they will be equiangular? Is there any such interdependency or interrelation is there between these two fundamental properties? This is very, very important. Let us try to explore them in this session only. So, if two triangles are equiangular, then instead of just saying that they are similar, can we show that the corresponding sides are in a position? Can we demonstrate this, children? Or if the corresponding sides are in a proportion, then instead of just saying that similar and stopping there, can we say that, can we show that they are equiangular? Is it possible to demonstrate like this, children? This is a very, very interesting point. This is called the interdependency of the two fundamental properties. Yes, the answer is clearly yes, children. But in order to prove all these properties, we require the help of another fundamental theorem on proportion, which we will learn in the next session. Let us now sum up all the concepts that we have learned in this session. So, if two triangles are similar, then they will be equiangular, so that we can conclude that we can also say that the corresponding sides are in a proportion. So, if two triangles are equiangular, then we can say that the corresponding sides are in a proportion. and hence we can say that they will have the same shape. Conversely to this, the corresponding sides are in a proportion, then they will be equiangular. The moment they are equiangular, you can simply say that they will be similar to each other. Children, this is the very first theorem in similar triangles called angle-angle theorem or AA criterion, and this is the converse to this. What can we call what we can call this as? This we will call it as SSS theorem, side theorem, which we are going to prove in the future classes. So similarity leads to equiangularity, and equiangularity leads to proportion. Here is a wonderful cycle is there, like carbon cycle, water cycle, nitrogen cycle, which you study in chemistry. In geometry also we can have a wonderful cycle like this, children. So this we will call it as similar triangle cycle. That is, if two triangles are similar, they will be equiangular, they will be proportion. Or in the anti-clockwise also you can read, if two triangles are similar, then the corresponding sides will be in proportion, and hence they will be equiangular. Or you can start from here. If the sides are in a proportion, then they will be equiangular and similar. Or this way, if their sides are in proportion, they are similar and equiangular. Finally, if two triangles are equiangular, then they will be similar and the corresponding sides are in a proportion. And converse to that, if two triangles are equiangular, they will be the corresponding sides will be in a proportion, and hence they will be similar. So this is how we can remember whatever we have discussed in this session. So in this session we have understood the concept of the idea of a similar triangle and the two important fundamental properties to that. Children, in our next session we shall understand the fundamental theorem on proportion, that is the basic proportionality theorem, which is briefly called as BPT, given by Thales, one of the greatest mathematician from Greece who lived in 600 BC. Children, time has come. Can you take down the homework? This is a very small homework, exercise 2.1. 3 mains are there. So I strongly recommend to keep a 200 pages a long notebook. Write down the questions and the answer, so that in our next class, before we start the lesson, I will share the answers for this. Okay. So thank you, children. Thank you. With our best wishes to you. Namaste, children. Namaste. ಇಲ್ಲ, 5 ಕಾಲ ಆಯ್ತು, ಒಂದು ಅರ್ಧ ಕಾಫಿ.
ಇದು 1 ಅವರ್ ಆಯ್ತು. ಈಗವರೆಗೆ ಮಕ್ಕಳಿಗಂತೂ ಕ್ಲಾರಿಟಿ, ಪ್ರಪೋರ್ಷನ್, ಅವತ್ತು ಮ್ಯಾಥ್ ಕ್ಲಾಸ್ ಇವತ್ತು ನೆನ್ಪು ಎಲ್ಲಿದ್ದವರು ಮ್ಯಾಥಮೆಟಿಕಲ್ ಥಿಯರಮ್ನ ಫಿಸಿಕ್ಸ್ ಥರ ಪಾಠ ಮಾಡಿ ಡೈಲಿ 1 ಅವರ್ ಸರ್
40 minutes session for
ಸ್ಟಾರ್ಟ್ ಆಗ್ಬಿಡ್ತಾರೆ ಸರ್ ನಮ್ಮ ನಾನು
ಮೋಹನ್ ಹತ್ರ ಫಸ್ಟ್ ಬಂದು ಇದೆಲ್ಲ ಎಕ್ಸ್ಪ್ಲೈನ್ ಮಾಡಿದೆ ಸರ್. ಅವ್ರಿಗೆ ಮಾಡಿ ಏನಾದರೂ ಕರೆಕ್ಷನ್ ಇದೆಯಾ ಅಂತ ಕೇಳಿಕೊಂಡು ಒಂದು ಫುಲ್ ರನ್ ಮಾಡಿದೆ. ಅವರು 50 ಸ್ಲೈಡ್ಸ್ ಇದೆ ಸರ್, ಇದು 50 ಸ್ಲೈಡ್ಸ್ ಆಗಿದೆ. ಅವ್ರ ಹತ್ರ ಮಾಡಿ ಆಮೇಲೆ ಓಕೆ ಮಾಡಿಕೊಂಡು ಆಮೇಲೆ
ವಂಡರ್ಫುಲ್.
ತುಂಬ
ನಾನು
ಚೆನ್ನಾಗಿದೆ
ಫಿಸಿಕ್ಸ್ ಕೇಳ್ತಿದ್ದೆ, ನಾವು ಮ್ಯಾಥ್ಸ್ ಅಷ್ಟು ಸಲ ಮಾಡಿದ್ವಿ
ಸರ್.
ಯಾಕಂದ್ರೆ ಎಲ್ಲ ಬರೀ ಮ್ಯಾಥ್ಸ್ ನಮ್ಗೆ ಏನಿದೆ ನಂಬರ್ಸ್, ಜ್ಞಾನಪ ಡ್ರೈ ಸಬ್ಜೆಕ್ಟ್ ಬರೀ ನಂಬರ್ಸ್, ಟ್ರಯಾಂಗಲ್ ರೆಕ್ಟ್ಯಾಂಗಲ್ ಅನ್ನಂಗೆ. ಬಟ್ ಇವತ್ತು ನೀವು ಮಾಡದೇ ಟ್ರಯಾಂಗಲ್
ಹೌದು,
ಏನ್ ಸಿಂಪಲ್ ಆಗಿದೆ ಒಂದು ಥಿಯರಿನ
ಸರ್. ಇದು ಪೆನ್ ಡ್ರೈವ್ ಮೋಹನ್ ಮೋಹನ್ ಅವ್ರು ಇಲ್ಲೇ ಇಡ್ಲಾ ಸರ್? ನೀವು ಕೂತಿದ್ದು ಒಂಥರ ಇನ್ಸ್ಪಿರೇಷನ್ ಆಯ್ತು ಸರ್.
ಇಲ್ಲ
ಇಲ್ಲೇ ಕೂತ್ಕೊಂಡು ಮಾತಾಡೋದು ನೀವು ಇದ್ದಿದ್ದು ಒಂದು ಸ್ವಲ್ಪ ಖುಷಿ ಆಯ್ತು ನನಗೆ. ಥ್ಯಾಂಕ್ ಯು. ಥ್ಯಾಂಕ್ ಯು. ಸುಮಾರು ಬಂತ ಇದೆ ಟೈಮು. ಇದೇ ಫಸ್ಟ್ ವಿಡಿಯೋನ ಇಲ್ಲಾಗಿತ್ತು.
ಮಾಡ್ತಾ ಇರ್ತಾರೆ.
ಈ ಬಾಕ್ಸ್ ಕಡೆ ಬೇಕಾದ್ರೆ. ಥ್ಯಾಂಕ್ಸ್ ಸರ್.
ನನ್ನ ಹೆಸರು ನವೀನ್.